This video describes an electrical circuit capable of sorting 4 numbers. Using the binary spaghetti sort algorithm to run the simulation, we're using logism-evolution. Here you have your 4 digits that you want to sort, and on the right you have the digits sorted. We will go through the various parts of the circuit one by one. First of all, we will see how it works. Here we can set the bits of the numbers that we want to sort. Mind you, they must be between 1 and 5, both included. And once you set your numbers, the circuit sorts them, and you see them sorted on the right. Let's see how this thing is assembled. The first step is spaghettization. We take each and every one of the input numbers, turn them into arrays of bits with zeros and ones, of course, because they are binary arrays, with a 1 in the position of the number that we want to sort. So for instance, number 4 is here, number 5 is here, number 1 is here, and so on and so forth. We achieved this by shifting an array of bits with the same number that is reported here, -1. Once we have these spaghetti, we can see them here on the right as they are in the binary spaghetti heads index. If you turn these red lights into binary numbers, you obtain the binary spaghetti heads index. And this is what we will be using to sort the numbers. We take the spaghetti one by one and we send them to this sort of bus, let's say. Attached to this bus, we have these modules that I'm going to describe in a moment that take each element in the binary head index individually. Other than this, they take a number that is a counter that tells to the module what are the available positions essentially. So it starts from 0, and as it sorts elements, it is increased. Like in this case, it takes 1 element, so the 0 is in the input, and we expect 1 in the output. The same goes for the second module, and so on and so forth. Once each model has decided whether it is going to take one of the spaghetti or not, and in case it took one of the spaghetti, it sends it to the digits up here so that they are in order. But now let's take a look at what is inside these boxes. In these boxes, we see a circuit that works just like the while loop in the source code, as described in the paper. Here we have a series of XOR ports that take the input value. This value is the value in the binary head spaghetti index, and it is processed 1 bit at a time with a mask that masks the bits one at a time, of course. And if it detects 1 bit, the counter is increased as one of the positions is taken, and eventually the count is sent as an output to be sent as an input to the following module. When one of these units detects one number, it picks it from the spaghetti that are sent as input to this module. So we have a series of plexers, one to pick the right spaghetto and one to send it to the right position according to the counter. We have another little unit here that it's used to set this output to 0 in case we do not detect anything, like in these cases down here. Finally, we have our spaghetto sent to the right position and outputted to the right XOR port, as you saw, that goes inside the digits. And this is pretty much all. But let's see very quickly what happens if we have 2 elements to be taken at the same time. So we will see what happens with the same module down here with the penultimate myloop2. So we want it to take another number like this. So we are adding another 4 to the sequence of numbers that we wanted to sort. Let's assume we switch this to 4, and there you have it. Now we can go to the module that will detect 2 bits. That it's this one. It has 2 light green lines. We go inside the module again, and we see that this time we have captured the first one with the first mask that masks one of these bits, and here you get as an output the value with just 1 bit set. So we captured this and we sent it to the right output port, but here it is XORed and it goes to 0. So we finish the loop. Basically, this is again the while loop. The counter is increased, and that's all. In this way, all the blocks down here, the my loop blocks down here, send their numbers to these ports here, and they are visualized in order, and this 4 digits appear. You can play around with the model that you can find in the GitHub repository, either linked in the paper that I invite you to give a look at, or the GitHub repository, where you will find also the code implemented in Python. And this is pretty much all. Thank you very much for listening